Okay, problem number 3, first of all, is asking us to find the standard error, which is what we just did in problem number 2. So it's just going to be applying that basic formula that we had from problem number 2. We will substitute into the formula. We will substitute that standard deviation, and we'll take that n value of 16 and substitute it into the formula. So this one is just plain old applying the formula. So you'll do that 1.25 divided by the square root of 16, round that to 4 decimals, and that gets me the answer to part A of sample problem number 3. Part B asks us, within what interval would you expect the sample mean to fall with 90% probability? And the book goes into a lot more detail about why. So by all means, pretty please look at that if you'd like to know. But we're going to use these formulas, and the short version of why is because of the central limit theorem. So we have some very common z values. We did z-scores back several weeks ago, and these z-scores are part of the formula. So a z-score for a 90% confidence interval is this one, 95 is this one, 99 is this one. Big hint, you're going to be needing these in the future. Now we are interested, due to the problem that we have before us. Which one are we interested in? We are interested in the 90% interval. So that means that we are going to use this formula right here. So this is the one that we're going to use. So make sure that we know what all these, lovely symbols mean. So I'm going to kind of highlight the pieces from the problem. So there is your mean. This is the z-score that corresponds with the 90% interval. Then we have our standard deviation, and n will be 16. So that is where I'm getting all the pieces from the problem to substitute into the formula. Before I do my calculations, as you can see, so I have to basically do the problem twice, right? Remember what this plus minus means? You see this a lot of the time in textbooks, and it just means that you're having to do an addition problem, then you're having to do a subtraction problem. So again, we saw where we got all the numbers from in the problem, so I got to do 27 plus 1.1645 times 1.25 divided by the square root of 16, and then we need to do 27 minus 1.1645 times 1.25 over the square root of 16. So you've got to do a version with it while you're adding and then you're subtracting. Sorry, my stylus is doing something goofy. Not sure what it's doing. So when I do all those calculations, I should end up with, when I added all of it, I should have ended up with this bigger number, typing it into my calculator, and I should have ended up with the smaller number once I put it in my calculator. And remember, this 1.645 just kind of sitting here next to everything means that you're going to multiply. So you're going to do 1.25 and divide it by the square root of 16, and then you're going to multiply it by 1.645. I'm going to add to the notes a link to that calculator that I love using, that I feel like really helps out a lot. So remember how to use this Desmos calculator. I'm going to do the addition first. So 27, oops, what up if I hit the 2? So 27 plus 1.645, and we're going to multiply that by, I'm going to hit the fraction button, 1.25, I'm going to click below, hit the little square root button of 16. And you see, I do get the same thing that I got over here in the notes a minute ago, the 21.514. Obviously, I rounded it but I do get the same thing. And then to do the subtraction piece, I'm going to clear it. Clear all. So then I just do 27 minus 1.645 times, I'm going to put in my fraction, 1.25 divided by square root button of 16. And there you see I get the number that I calculated for the lower side of my interval.